The Alliance Hypothalamus Artificial Intelligence, CISNERIA Engineering, and Gurobi Optimization. It is your ideal partner for the implementation of artificial intelligence decision systems during the Industry 4.0 revolution. Hypothalamus Artificial Intelligence, CISNERIA Engineering and Gurobi Optimization have agreed on a technology alliance to jointly provide services to the special transport sectors, based on highly complex mathematical models. The technological capabilities of the three companies, in artificial intelligence and mathematical programming, make them ideal partners to face the multiple challenges that exist in advanced analytics applied to the transport sector. Due to the experience of the two companies, this alliance is particularly strong for the optimization of special transport systems such as the aviation industry, planning and operation of ports, and rail systems. Public benchmarks consistently show that Gurobi finds both feasible and proven optimal solutions faster than competing solvers. With Gurobi powerful MIP algorithm, the user can add complexity to its model to better represent the real world and still solve your model within the available time. The performance gap grows as model size and difficulty increase. Gurobi has a history of making continual improvements across a range of problem types, with a more than 75 times speed up on MILP since first version. Gurobi is tuned to optimize performance over a wide range of instances. Gurobi is tested thoroughly for numerical stability and correctness, using an internal library of over 10,000 models, from industry and academia. CISNERIA is an engineering and optimization company, specialized in the development of tools to support decision-making. Through academic research, and the conception of mathematical models, CISNERIA add value to companies by improving their production processes. The main sectors in which CISNERIA work are air transport, railways transport, and defense. The intellectual property of hypothalamus artificial intelligence is supported by our methodologies and technologies that has been used for 50 years developing and implementing highly complex mathematical model and decision-making systems at enterprise scale. HI has developed a robust library of successful algorithms for application development and use cases across large multi-regional enterprises. 80% of our process of computation systems generation is executed by AI agents, which ensures, for high-complexity models, that is at least 1,000 times faster than an army of programmers. HI solution is universal, it is standardized, and it is easy to adapt and implement, satisfying the demands of fast digital transformation. HI methodology is based on artificial hypothalamus framework, and they use real-time autonomous distributed optimization, allowing algorithms to evolve, generating self-learning processes, minimizing human intervention. HI solutions produce an average reduction of 10 to 15% in users' operating cost. HI is the creator of the artificial brains, a disruptive mathematical modeling methodology. The artificial brains corresponds to the scientific foundations, more specifically mathematical fundamentals, that allow to connect multiple mathematical models, algorithms or robots, exchanging information between them to obtain a common goal, and act as holistic intelligence of the organizations, or parts therein. Like the human brain, the artificial brain is composed of the following artificial components: neocortex, hypothalamus, and hippocampus. Workforce management, crew and drivers planning and scheduling, and staff rostering and scheduling. Fleet management, fleet planning and dispatching, network planning, and timetabling. Asset management, airport resource allocation, crane scheduling, vehicles maintenance, and warehouse resource scheduling. Yield management, pricing, and dynamic packaging. These applications are general for the entire industry, regardless of the mode of transport. For example, optimized workforce management, in all cases implies staff sizing regulation, rostering, timetabling, and task assignment, monitoring and control. The benefits of operations research applications are cost takeout and operational efficiency, reduce costs of capital and cost-intensive resources and assets, capital expense avoidance or deferral, and better use of limited resources. Optimized workforce and improved customer service, increase quality of service and reactivity, more on-time deliveries and responsiveness, and improve employee effectiveness and satisfaction. Measurable ROI and improved profit, increased revenue and improved revenue mix. Improved market agility and reduced risk, respond to change quickly with improved planning. Smarter, greener planet, less carbon emissions and lower carbon footprint. Examples of applications of operations research in aviation industry are: optimized fleet management includes fleet planning, fleet scheduling, fleet tracking, and freight tracking. Optimization of smart operations in ports. Mathematical programming in logistics operations in ports supports the following decisions: strategic level terminal allocation, and capacity planning. Medium-term tactical planning, berth allocation, macro yard planning, and maintenance of equipment. Short-term planning, stowage planning, key crane assignment, auto loading, and discharge, yard micro-planning, manpower scheduling, vehicle routing, and maintenance scheduling. Operational scheduling, manpower scheduling and dispatch, vehicle dispatching, and stowage replanning. Below applications of operations research in railway sector are presented. The following activities have been modeled using operations research in the rail freight industry. Routing: given the demand for rail freight transport, the set of operating policies under which routes will be assigned to trains and cargo must be established. Blocking: it specifies how blocks are constructed in each classification yard of the rail network. Blocks: they are the set of wagons that are grouped, since they share some initial portion of stations in their route, although their final destination is not the same. Classification yard: they are nodes that belong to the railway network where loading, unloading, classification of wagons, according to their destination, assembly of the same, etc. are carried out. Makeup policy: it specifies the list of possible blockages that can go on the output train. While the blocking models indicate the route to be followed by the load, and the distribution of the sorting work in the yards of the network, the routing and makeup models determine the routes and frequency of the trains, and the assignment of the blocks to the trains. In this way, the complete route and cargo allocation plan is composed of these three activities. Railway operations planning. Scheduling, timetabling. It is the generation of a schedule, which accommodates all train planning, satisfying the restrictions of the capacity of the railroad and the yard. Handling freight cars: it consists of the dynamic distribution of empty wagons in the network, so that the associated transport costs are minimized. Locomotive assignment: it is the assignment of the set of locomotives to the programmed trains, at the lowest cost, while satisfying the constraints of compactness and maintenance. The mathematical models used in railway operations planning are: projected demand for rail transport services, optimization of the blocking process, construction of timetables for trains, allocation of locomotives to trains, and assignment of crews to trains. Like Herbert Simon, hypothalamus, CISNERIA and Gurobi believe that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.